Hello everyone, myself Soumya GS from 4th SEM ISC. Today I am here to present a problems on permutation and combination. So let's see. So what is permutation and combination? So we'll see what is permutation. So permutation relates to the act of arranging all the members of a set into some sequence or order where order of the arrangement matters. So here anything we take the order of any things, letters, etc. the arrangement matters. So understand this line. Let us take one example. So we have three letters. Let us assume A, B, C, and we have to arrange two letters at a time. So then the permutation would be AB, BA, BC, CB, AC and CA. Here you can see AB is present and BA is also present. You see AB and B are not same, right? So here because the order of arrangement matters. So similarly we can see another one example. So considering the same, so arranging all the letters simultaneously, so the permutation would be ABC, CBA, BAC, CAB, BC and ACB. So to solve the permutations problems, so the formula would be, so the permutations of R things from a set of n at a time, that gives NPR. So selecting n things and n minus 1, n minus 2, that gives n factorial by n minus r factorial. So next we'll see what is combination. So the combination is a way of selecting items from a collection such that unlike permutations, the order of selection does not matter. Here the order of selection of things does not matter. So to understand this line, we will see one example now. So when the number of things, that is x, y and z, then the number of combinations taking two at a time will be xy, yz and zx. So here I'll have given some note like xy and yx are same in the combinations, right? So here selection does not matter. So xy and yx both are same. So we'll see another similar example. So the combination of all the things gives x, y, z. So here also z by x is same, y x z is same. So here you can take anything. So the formula to solve the combinations would be, so the choice of r things from a set of n things without replacement and where order does not matter. So that gives NCR, that is equal to NPR divided by r factorial. So before only you know the NPR formula, so that is n factorial by n minus r factorial into r factorial. So how this permutation and combination works? So we are confused, right? Whether to do addition or multiplication. So to know, so we'll see some important formulas. So here we are seeing NCN, that gives 1. So that is selecting n things out of n, that gives 1. So similarly NC0 is equal to 1, NCR is equal to NCN minus R, NCR plus NCR minus 1 is equal to n plus 1 CR, NCR is equal to n minus 1 CR plus n minus 1 CR minus 1. So here we will take rule of addition. See that if a first task is performed in X ways and second task is performed in Y ways, then either of the two operations, so either X and Y, either of the one can be performed in X plus Y ways. So rule of multiplication means, similarly if a first task is performed in X ways and second task is performed in Y ways, then both of the two operations can be performed in X into Y ways. So whether permutation or combination. So again confused. So whether to do permutation or combination in a given question. So to know that, we'll solve some important problems. So that you can come to know whether to do permutation or combination. So here is your first question. So in what ways the letters of the word rumor can be arranged? So here are the options. So the answer gives A. So let us see how. So the rumor contains 6 letters, right? 1, 2, 3, 4, 5, 6. Here at first I will say the general formula. So if they are given n letters, Like example, I am taking n letters, n things, etc. If they are n, so they can be arranged in n factorial ways, right? So here there are 6 letters, so here they can be arranged in 6 factorial ways. But remember, when the repetition of letters are there, so here you can see R is repeated and U is also repeated, right? So how many number of times they are repeated, you should divide by the repetitions. So here 2 times if they are repeated, so U and R, so 2 factorial into 2 factorial, that gives 180. So the option is A. So the next question is, in what ways the letters of the word puzzle can be arranged to form the different new words so that the vowels always come together? So here are the options. Let's see. So the answer is G240. So I'll say how. So here you can see there are 6 letters in the puzzle, right? So they are asking to form different new words where vowels come together, always come together, right? So here you can see U and E are 2 vowels. So taking U and E, so here you can see I am taking U and E as one entity. So now if you take U and E as one word, that is one word means that is one entity, right? So now the remaining here are 4 letters. So the total becomes 5. So there are 5 letters and there are 5 arrangements possible. See 1, 2, 3, 4, 5. So 5 places are there, right? So it becomes 5p5. That gives 120. But always remember, so when you are considering the entity, so they can also be arranged in different ways. Okay, so here you can see U and E can be placed in 2 factorial ways. How? UE, EU, right? So 2 factorial means 2 into 1, right? So these are the 2 possible arrangements. So as there are 120 words, so there are UE different possible arrangements. So you should multiply them with 120 into 2 gives 240. So the answer is 240. The next question is, in what ways can a group of 6 boys and 2 girls be made out of the total 7 boys and 3 girls? So here are some options. So we'll see. So the answer is C. So at first, let us assume this is the group of 7 boys and 3 girls, and we know the relation of equality, that is NCR is equal to NCN minus R, as I previously said. So they are asking the combinations, right? Easily we can say that is they are the combinations of boys and girls, that is 6 boys and 2 girls, out of total how much it is, 7 boys and 3 girls. So it is easy, right? That is 7C6, that is 7 total number of boys, 6 is selecting out of 7. So 3 is total number of girls, 2 is selecting out of 3. So solving that, using this relation we are solving. So solving that gives 21. So the option is C. So the next question is, a group consists of 4 men, 6 women and 5 children. In how many ways can 2 men, 3 women and 1 child selected from the given group? So let us see, here are the options. So the answer is option B. This is also simple. Let us consider this is the group of 4 men, 6 women and 5 children. So they are asking the combination, right? So you can easily see they are asking the combination of 2 men, 3 women and 1 children. So it is also multiplication that in which a group simultaneously should be occurred, that is 2 men, 3 women and 1 child. So 4C2 gives 4 men, that is 2 selecting out of 4. So that is 6 is the total number of women. So 3 is selecting out of 6. So 5 is total number of children. So 1 is selecting out of 5. So this solving this gives 600 best. So the option is B. So the next question is, a box contains 2 red balls, 3 black balls and 4 white balls. Find the number of ways by which 3 balls can be drawn from the box in which at least 1 black ball should be present. So here they are asking drawing a 3 balls, right? How many number of ways a ball, 3 balls can be drawn in which at least 1 black ball should be present. Here you should understand at least means greater than or equal to. If we are drawing 3 balls in which it can be 1 black ball or more than 1. So here you can see the answer is A64. So the possible combinations I'll explain you. So here the three balls are drawn, in which one black ball is compulsorily present and two balls are non-black balls, right? It can be either white or red or white or red. This is vice versa. So again the second combination is, so two black balls and one white ball or red ball. So in which one black ball is compulsorily present, right? So another one combination is also present, in which three balls drawn is also black balls. So in which one black ball is compulsorily present, right? So all these combinations are present. So they are asking the number of ways, right? It can be occurred this or this. Any one combination is also possible. So we are doing addition, right? So solving this gives 64. So the answer is 64. So the next question is, out of 7 constants and 4 vowels, how many words of 3 constants and 2 vowels can be formed? So here are the options. Let us see. So here you can see the answer is B. So at first let us consider this is the group of 7 constants and 4 vowels. So here they are asking how many words, right? Words means what? It is a combination of constants and vowels. They are asking that 3 constants should be there and 2 vowels should be there. So if a word is formed by these two, so it is a combination of constants and vowels. So obviously it is a multiplication, right? So both should be present in a word, right? Simultaneously. So 7 is total number of constants, 3 is selecting out of 7, and 4 is total number of vowels, 2 is selecting out of 4. So this gives 210. So that means 210 groups having 3 consonant and 2 vowels. Like we can see 210 words, right? So but every word contains 5 letters, right? They can be arranged in 5 factorial ways. So here they are asking without meaning. They are asking without meaning, right? Like 5 letters can be arranged in 5 factorial ways. So multiplying total number of words with that 5 letter arrangement gives total number of words formed. So that is 25,200. That is option B. So the next question is, how much 4-digit number can be formed from the digits 2, 3, 4, 5, 6 and 7, which are divisible by 5 in such a way that digits should not repeat. So here repetition is not allowed. You can see. So the answer is D, 60. I'll explain you how. So at first you should know the concept of divisibility of 5, right? So when the number is divisible by 5, so when the ones place is 0 or 5. So in the given numbers there is no 0, right? You can't place anything because 0 is not present. But 5 is present, right? So you can place 5 in ones place. So there are 1, 2, 3, 4, 5, 6 numbers. So out of 6 you have placed 5. So the remaining are 5 letters, right? So remaining 5 letters you can place any one of the number in tens place. So after placing in tens, so the remaining are 4 digits. So in that remaining 4 digits you can place one of the digits in hundreds place. So after placing them, the remaining is 3 digits. So remaining 3 digits, like we can place one number in thousands place. So multiplying the number of digits, like 1 digits in ones place, 5 digits in 2 place, 4 in hundreds and 3 in ones is equal to 60. Why we have stopped to 3 here? Because they are asked only 4 digits, right? So 1, 2, 3, 4, right? So multiplying gets 60. So the answer is 60. So the next question is, how many 4-letter words with or without meaning can be formed out of the letters of the word logarithms if repetition of letters is not allowed? So here are the options. So let us see. So the answer is option C. So it is simple. So you can see logarithm contains 10 letters, right? So out of which they are asking 4-letter words. So in out of 10, 4-letter words is chosen. So in which with or without meaning means like 10p4. So that is total number of arrangements of letters with or without meaning. So it gives 10 into 9 into 8 into 7. So that is 5040. So the option is C. So next question is, so in what ways the letters of the word machine can be arranged so that the vowels occupy only the odd positions? So here are the options. So I'll explain it. So the answer is C, 576. So here you can see I have taken some example. So the word machine contains 7 letters, right? So in which 3 vowels, which are there? So A, I, E, right? And 4 constants, M, C, H, N, right? So they at first they are asking to arrange vowels in only odd positions. So how many odd positions are there? 1, 2, 3, 4, right? But only 3 vowels are there. You can place ear, 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 or ear, 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 anywhere, in which only the odd positions are present. So there are only 3 letters, that is 3 vowels, out of 4 positions are there. So that is 4p3. Similarly, when odd positions are occupied by 3 vowels, remaining 1 odd positions and 3 even. So that becomes 4 positions, right, to fill constants. So there is no constraint for the constants. So we can place 4p4, so that gives 24. So multiplying both of the arrangements, that gives total number of ways. So that gives 576. So the option is C. So the next question is so similar to the previous one. So I'll explain it. So in what ways the letters of the word actors can be arranged so that the vowels occupy only the even positions? So in the previous one they asked about the odd positions, right? So here they are asking about the even positions. So at first actors contain 6 letters, right? So at first how many vowels are there? Here also they are asking to occupy vowels. So A and O, only 2 positions are there. But even positions are 3. 1, 2, 3. Right, first 1, 2, 3, right? So only 2 vowels are there, out of which 3 places are there. So 3p2, right? So that gives 6 ways. Similarly, the remaining when 3 even positions are there, but only 2 are filled, but remaining are 4, 1 even and 3 odd. So total is 4p4, that gives 24. So multiplying both of them gives total arrangements. So the next question is, a boy has 9 trousers and 12 shirts. In how many different ways can he select a trouser and a shirt? So this is very simple. So the answer is option D. So let us consider this is 9 trousers and this is the 12 shirts. So here they are asking to select one trouser. So one trouser can be chosen anything, right? This can be chosen, this can be chosen. So there are 9 ways. So here also 12 shirts can be chosen in 12 ways. So you can take this, 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 this. So multiplying both of them gives total number of ways. So it is easy. So the next question is, 3 dice each having 6 faces with each face having one number from 1 to 6 are rolled. What is the number of possible outcomes such that at least one dice shows the number 2? So here are the options. So the answer is option C, 91. So at first I'll tell you the general approach. So at first let us take one example like tossing a coin. So generally the coin has 2 faces, right? So the possible outcomes of tossing a coin is 2 per n, where 2 is the number of faces and n is the number of coins. So similar approach can be done for the dice also. So here there are 6 faces in dice, right? 1, 2, 3, 4, 5, 6, and it can, the possible outcomes means 6 per n. So here we have taken 3 because there are 3 dice. So the total outcomes is 16. So here they are asking, so at least one dice shows the number 2, that is greater than or equal to 2, right? So at first we'll come with backtracking method, like finding the outcomes of 2 becomes difficult. At first we'll find the outcomes of 2 are not appearing 2, and then we'll find the appearance of 2. So the leaving 2, that is does not appear, means the 2 doesn't comes, right? So this will disappear. So 1 2 3 4 5 aces are there, but 3 dice are tossed, I mean rolled, that is 5 par 3, that gives 125. In 125 outcomes 2 doesn't comes. So when the 2 comes, like subtracting 125 with 216, that gives the outcomes showing 2. So that is 91. So the option is C. So the next question is, using all the letters of the word Nokia, how many words can be formed which begin with N and end with A at first? So we will see the option is B, because there are 5 letters in the given word, right? So Nokia has 5. 1, 2, 3, 4, 5. Like I have left this to explain. So here you can see 1, 2, 3, 4, 5 letters, right? So consider 5 blanks. So here I am considering 5 blanks. 1, 2, 3, 4, 5. So the first blank and the last blank must be compulsorily filled with N and A. So they are asked to fill N in the beginning and A with the end. So N and A are fixed, right? So they are asking the total number of arrangements with Nokia where N and A are fixed. So the remaining is 3 letters. These 3 letters can be arranged in 3 factorial ways. So that is 6 factorial. 3 factorial, that gives 6. 3 into 21, that gives 6. So the answer is B. So next question is, how many 4-digit numbers can be formed using the digits 1, 3, 4, 5, 7, 9? So here you can see, so there are 4 digits numbers that can be formed using the digits. So here they are forming 4-digit number using these numbers. So where digits, repetition of digits is not allowed. So here repetition is not allowed, so obviously permutation comes into picture. So totally 6 letters, out of which 4 letters is to be 4 digits should be chosen. So it is simple, 6 into 5 into 4 into 3, that gives 360. So the option is A. So this is 4-digit numbers, right? So in how many ways can 5 boys and 3 girls sit in a row such that all boys sit together? So here are the options. So let us see. So the option is C. So let us consider this is the group of 5 boys and 3 girls. Assume see 1, 2, 3, 4, 5 and 1, 2, 3, in which all boys should be placed together and remaining, obviously 3 girls are remaining, they can be placed together. So treat all boys as one unit. See here, and now 4 students, and that can be arranged in 4 factorial ways. See, that is how this is considered as one entity, right? Like one unit. So remaining is 3. So 3 plus 1, 4. That is 4 ways. So total this becomes 4. So again 5 boys can be arranged in 5 factorial ways. So total we have found. So again these 5 boys can be arranged in 5 factorial ways. So multiplying them gets 2880. So the option is C. So I think you understood. So thank you.